Good morning, guys. Going to go over the review sheet that I gave you guys yesterday. All right. You guys have your quiz tomorrow. This review sheet looks very, very, very similar to what you should expect tomorrow. All right. So I'm going to go through each of these. Sorry, couldn't be in school doing it, but wasn't allowed to go into the building today. But this should do well. You should be able to skip through it. I'll make it so you can skip through it. So you can go to any problem you want to go to. All right. All right. First one. All right. So finding absolute extrema. All right. That means we're finding the absolute max and the absolute min. All right. So remember, absolute max and mins only occur on critical values or the endpoint. So the first thing we have to do is find the derivative. All right. The derivative of 3x to the fourth is 12x cubed. The derivative of negative 4x cubed is negative 12x squared. Set that equal to 0. I apologize for the sawing in the background. One of the reasons why it makes it harder for me to live teach. I got construction going on in my house. All right. So we have take out a 12x squared and it'll leave me with x minus 1. Set that equal to 0. So when I set that equal to 0, I get 0. When I set this equal to 0, I get 1. So my critical values are 0 and 1. All right. So then you make a table of values. Your x coordinates are your endpoints, which are right here in the interval, and your critical values. As long as the critical values are in that interval. 0 is in the interval, 1 is, but we already have 1, so we don't have to list it twice. Now, to find our y's, you plug back into the original, not to the derivative. All right, you plug back into the original, not to the derivative. So when I plug in negative 2 to the fourth is positive 16. 16 times 3 is 48. Negative 2 cubed is negative 8. Negative 8 times negative 4 is positive 32. All right, so 48 plus 32 gives us 80. All right, plug in 1 is 3 minus 4, which is negative 1. Plug in 0, you get 0. So then you just have to look to see what is the highest. Obviously, negative 2 comma 80 is the highest, so that's my absolute max. My min would be negative 1. We're looking at the y values, all right? So that's 1, negative 1. All right, so that's how you find absolute max and min. Find the critical values, plug the critical values and the endpoints in to the original, and then whatever highest y values, your absolute max, lowest y values, your absolute min. Okay. All right, now we have to do Rolle's theorem. All right, now notice there's 2 problems here. If I give you 2 problems, most likely one of them will work, one of them won't. And the same thing's true for mean value theorem. It could be tomorrow that you have 2 mean value and only 1 Rolle's, whatever it may be. If you have 2 of one of them will probably work, one of them won't. If you only have 1, I guarantee it will work. Now, if you remember, for Rolle's theorem, the first thing you have to check is if it's continuous. The only way something won't be continuous is some sort of fraction, which we have here. And what you have to look at is to see what makes the bottom equal to 0. In this case, x equals 2 makes this not continuous. Then you have to see if 2 is on the interval. 2 is between 0 and 4. So the first thing we're supposed to check is that the function is continuous on the interval. This is not. So you're done with this problem. So Rolle's theorem does not apply. All right, and that's because it's not continuous. All right, it's not a continuous function. All right, so since that one didn't work, you could probably make a pretty good assumption that this one will. All right, so we have no fraction here, so it's going to be continuous. So you just write, I know it says y, but just write f of x, it's fine. Or f. It's continuous on the interval, and write the interval out from 0 to 6. After you say it's continuous, you have to say that it is differentiable. I'm not going to give you one that's not differentiable. Okay. And then the third thing you have to check is you have to plug in each of the endpoints into the original, and you have to get the same y value. So when I plug in 0, 0 minus 0 is 0. Plug in 6, 36 minus 36 is also 0. So that means that Rolle's theorem applies, which tells us that there is at least one spot in this interval where the derivative equals 0. So we do 2x minus 6 equals 0. X equals 3. And there's our answer. And 3, just check to make sure 3 is on the interval. It is. All right, so that's Rolle's. All right, remember I said there's 2 of them. One of them probably works. One of them probably doesn't work. All right. Now, mean value. Notice here, I only have one mean value theorem problem, which means that this will probably work. The nice thing about mean value is, whoa, happened there. Sorry. The nice thing about mean value theorem is that you only have 2 things to check, and it's the same first 2 as Rolle's. So we have a fraction here, but x is not in the bottom, so we don't have to worry about it not being continuous. So f of x is continuous on the interval, and f of x is differentiable. So it's differentiable on the interval from 0 to 2. Okay, so since those 2 things are true, we know the MVT, or the mean value theorem, applies. All right. Now remember, what the mean value theorem says is that there is one place where the instantaneous rate of change, which is the derivative, is equal to the average rate of change, which is the formula, which is like the old slope formula, f of b minus f of a over b minus a. All right, so you just need to find each of those and set them equal to each other. So the derivative 1/4 x cubed is 3/4 x squared. The derivative of 1 is obviously 0, so there's our derivative. All right, so now I have to do f of 2 minus f of 0 all over 2 minus 0. All right, f of 2, 2 cubed is 8. 1/4 of 8 is 2. 2 plus 1 is 3. When I plug in 0, I get 1. So I get 2 over 2, which is 1. So I have 3/4 x squared equals 1. That's what I want to solve for. So I'm going to multiply by 4/3 on both sides, and I get those cancel, and I get x squared equals 4/3, and I take the square root of both sides, and obviously it should be plus or minus, but obviously the negative is not between 0 and 2. So the answer is the square root of 4/3. You can check 4/3, square root of 4, that is between 0 and 2. So that is the mean value theorem. All right, now for these types of problems, all right, the nice thing is it's split up. The left side all has to do with the first derivative. The right side all has to do with the second derivative. All right, so there's going to be 2 problems like this. One's like A, which would be a polynomial, which you guys should be able to do the derivative on your own. The second one's going to be a fraction, which I will give you the derivative. All right, so this derivative is 6x squared minus 12x. When I set this equal to 0, I take out a 6x, and I'm left with x minus 2. So I get 0. And when I set that equals 0, I get 2. So my critical values are 0 and 2. All right, so now when you use this number line, you're plugging into the derivative. You plug into the derivative. So anything negative, so a -1, that would give me a negative here and a negative there. A negative times a negative is a positive. If I plugged in 1, I would get a positive here. 1 minus 2 is a negative. Positive times a negative is a negative. Anything bigger than 3, 2, sorry, like 3, would be a positive there, positive there. Positive times a positive is a positive. So anywhere where the derivative is increasing, that's where, derivative is positive, that's where the original is increasing. So from negative infinity to 0, union 2 to infinity, and then it's decreasing from 0 to 2. All right, wherever the derivative is negative. All right, now for the relative max and mins, you look to see where it changes signs on the number line. So it changes at 0 and it changes at 2. And then you have to figure out if it's a max or min. So if something is increasing and then decreasing, you can see that is a max. So you put the x coordinate there. Where it's decreasing and increasing, that is a min. So that is 2. To get the y coordinate, you have to plug back into the original. Anytime we're doing y, we plug x in the original. When we're doing all this number line stuff, that's always the derivative. So when I plug in 0, I get 2. That's an awful 2, sorry. When I plug in 2, let's see, I get 8 times 2, which is 16. 2 squared is 4, which is negative 24, plus 2, negative 8 plus 2, negative 6. So a relative max at 0, 2, and a relative min at 2, negative 6. All right, so now we do the same thing we just did, but now we do it with concavity with the second derivative. So the second derivative, we take the derivative of the first derivative. The derivative of 6x squared is 12x. The derivative of negative 12x is negative 12. We set that equal to 0, we get 1. So there's only one critical value. Remember, what we do on the number line, we plug back into the derivative. So when I plug in 0, I get a negative. I plug in 2, I would get a positive. Wherever the second derivative is positive, that's where it's concave up. So you just write that interval. Down is where it's negative, negative infinity to 1. Points of inflection happen where we change sign. Just like max and mins happen first derivative, that's where points of inflection are. You just don't have to worry about if it's negative to positive or positive to negative. So obviously it changes at 1. So I have a point of inflection at 1. That's where it changes concavity. I then plug back into the original, plug back into here to get your y. You always plug back in the original. So I get 2 minus 6 plus 2. I just plugged 1 in for all these x's. So that gives me negative 2. And there's our point of inflection. Okay. All right, last one is our fraction. Okay. Now remember, I told you guys yesterday in class that that's a 2. And I told you that the derivative, first derivative was x squared minus 4 over x squared. And I believe this was, second derivative was 8 over x cubed. And I will give that to you on, that's, oh my God, that's a 3. I will give that to you on your test tomorrow. Be the same, like I said, same setup. The one fraction, I will give you the 2 derivatives. All right, so now that we have those 2 derivatives, when you have a fraction, okay, first thing, in the original, whatever makes the bottom equal to 0 is going to be a vertical asymptote. So I have a vertical asymptote at x equals 0, which is going to affect our answers to these problems once we do the number line stuff. So just be aware that the vertical asymptote is x equals 0. Now, to find critical values, when you have a fraction and a derivative, you set both the top and the bottom equal to 0. When I set the top equal to 0, I get plus or minus 2. When I set the bottom equal to 0, I get 0. Now, this is where you got to be careful. I know that a vertical asymptote happens at x equals 0. Draw that on your number line. It'll help you not make a mistake when you're answering the questions below. All right. So besides that, it's the same thing that we did on the previous problem. You're plugging into the derivative. So when I now notice that no matter what I plug in here, positive or negative, the bottom is always positive, right? Because anything squared is going to be positive. So whatever the top is, that's what the whole thing's going to be. So if I plug in negative 3, negative 3 squared is 9. 9 minus 4 is positive 5. So that's a positive. Plug in negative 1. Negative 1 squared is 1. 1 minus 4 is negative 3. So that's a negative. I plug in 1. 1 minus 4, again, a negative. Something bigger than 2 is going to give me a positive. So increasing wherever it's positive. So it's negative infinity to negative 2, union 2 to infinity. It is decreasing. Now, notice this. It's decreasing here. If this vertical asymptote wasn't here, it'd be negative 2 to 2. But since the vertical asymptote is there, I have to split them up. That's why I think it's helpful to draw that in there so visually you can see that and know that you have to put a union sign in between. Otherwise, you might just put negative 2 to 2 and then get that part wrong. All right, for maxes and mins, you see where it changes concavity. Well, it changes here. Now be careful. Is negative 2 an asymptote? Nope. So it's positive to negative. That is a max. Sorry, it's a max. Here, it goes from negative to positive. That is a min. Now, if it did change at 0, we wouldn't have a max or min there because of the asymptote. So then, once again, remember, we have to plug those back into the original. All right, so the original was x squared plus 4. So if I plug in negative 2, I get 4 plus 4, which is 8. 8 over negative 2 is 8 over negative 2 is negative 4. Sorry, it was a little. When I plug in positive 2, I get 2 squared is 4. 4 plus 4 is 8. 8 over 2 is a positive 4. So I got those by plugging back in to the original. All right, by plugging into the original. All right, so now everything here has to do with the second derivative. If I set 8 equal to 0, I get no critical values of that. Set the bottom equal to 0. So the only critical value is 0. But remember, what is 0? 0 is a vertical asymptote. All right, 0 is a vertical asymptote. So that's going to come into play potentially. So here, I plug in a negative number. 8 positive number over a negative cubed is a negative. When I plug in something bigger, I get a positive. So it is concave up wherever it's positive. So from 0 to infinity, and is concave down from negative infinity to 0. Points of inflection, it's where it changes. Look, it changes from negative to positive, but there's an asymptote. So we do not have a point of inflection. You must put like a slash mark, or you can write none. Don't leave it blank. If you leave it blank, I don't know if you really know what the answer is. All right. All right, so hopefully that clears up any questions you have. If you still have questions, please reach out to me. All right, the quiz will look just like this. All right, same types of problems, same number of problems, and everything. All right, if you need more practice, there's other problems that we've done in the past. Just look back at them. All right, and like I said, if you have any questions, reach out. Otherwise, enjoy the rest of your day, and I'll talk to you guys tomorrow.